important no, learnings. Important learnings. Point number one is the pending topic, process capability analysis. Process capability analysis, CPCP case study, becomes important and essential if the characteristic dealt, or if you want a particular characteristics of a product to be within the requirements or to meet the requirements, then CPCP case study is important. Another important topic we are going to talk today is hypothesis testing. I hope all of you remember the introduction to hypothesis testing has been already taught to you. Yes or no?
Yes, sir.
Yes, sir.
So basic terminologies, null hypothesis, alternate hypothesis, type 1 error, type 2 error, p-value, decision rule, p-value below 5% reject the null hypothesis, above 5% fail to reject the null hypothesis. I will help you gain proper clarity on the same topics. Then we will discuss few case studies. Using Minitab software, right? So this is today's agenda. And again, this is going to be very intensive and fully packed session. I want all of you, to be active, right? And one way you can express your participation is you can just stay on the camera, and then your face expression itself can help me to understand whether you follow the concepts I explain or not, right? And you can ask questions, and as usual, don't hesitate to ask the questions at any point of time. Okay, so what I do is I just share my screen, and since the session also involves the usage of Minitab, straight away I'm just opening Minitab, and I'm not going to use the PowerPoints. Rather, I'm going to focus on helping you understand the topic, right? So Minitab is opening now. Now let us start with process capability analysis, CPCP case study. This is first of all very popular in manufacturing industry. But if you understand how the manufacturing industries conduct the process capability analysis, and if you understand the terminologies and the situation where you can actually go for the capability analysis, you can also use the similar study. You may be working in pharma industry, healthcare industry, or you may be working in logistics, supply chain, or you may also work in manufacturing or other service industries. In all those domains, yes, CPCP case study is applicable. And I have even cases where the restaurant, the chain of restaurants, they have used the CPCP case study to maintain their food temperature during the dining hours. So the point is the data must be measurable. Even before that, let me tell you, if a field failure happens, if your product fails before warranty, or if your product fails in the field, it simply gives you a signal that something is going wrong when you actually produce the product. Yes or no?
Yes, sir.
If the field failure happens, see, even imagine you are even doing 100% inspection. You're doing 100% inspection and everything is meeting this customer requirement. What is customer requirement? Customer always have a target. There is an upper limit. We call it upper specification limit. And he has a lower limit called lower specification limit. It is nothing but what? Nothing but a product characteristics. Nothing but a product characteristics. Product characteristics. A simple example. It can be thickness. If the thickness is more, then there can be interference. If the thickness is less, there can be loose fit. And in both both can lead to a prod failure. Yes or no? And hence the failure at the product level. So now, if a field failure happens, even though you tested, you inspected 100%, all the parts are well within the specification. The specification, maybe let me type something. Thickness should be 12 mm. Oh, sorry. 12 mm plus or minus 0.5 mm, right? I'll make it a little bigger. Let's say the thickness is 40 mm plus or minus 0.5 mm. That means what is the upper specification limit?
39.5 to upper is 40.5, lower is 39.5.
So now you need to understand the parts that have dimension closer to 40 are really good quality products. Yes or no? But the parts that have dimensions closer to the specification limits, they are poor quality products. All right. So you can easily understand that with the help of the bell curve also. Perspective and load spec, right? And now here is your bell curve. And imagine your bell curve exactly fits here. I mean, your bell curve exactly fits within the spec. That means the same becomes upper control limit. The same becomes lower control limit. This is the scenario. We'll understand this little later. This is a scenario called CPCBK is also equal to 1. That means your process is just meeting the requirement. And now you consider the central portion. First of all, at the center, the mean will be there. Mean is, let us say the mean is 40. Right? The upper control limit, let us say it is 40.5, 39.5. Now this central portion, the central portion represents all the parts that have dimensions closer to 40 mm. Yes or no?
Yes, sir.
So these are products, that have high quality. These are products that have high quality. But if you consider this region, what is this region? This and this. They will have moderate quality. But if you consider this region and similarly this region, they are very closer to the spec. And I can say they are of low quality.
No.
But please note, all of them are meeting the customer requirement. All of them will pass through the 100% inspection. Am I correct?
Yes.
So now what is important for you to prevent field failure? And your 100% inspection cannot guarantee, a longer life, cannot guarantee durability, cannot guarantee field life. It is just passing through the inspection. At the time of inspection, it is meeting the requirement. When you start using the parts, it can undergo wear and tear and quickly go out of spec. So if field failure is happening, your 100% inspection really cannot, detect the field failure. It will only check, whether the parts is within the spec or not. So 100% inspection is not the way to ensure quality, particularly the, what do you call, the durability of the product, particularly the field life. If you are concerned about the field life, what you need to do is you should focus on producing more of quality, more of, I would say, not even a quality, premium quality, because all of them are meeting the customer requirement. The basic quality definition is fulfilling. But the problem is you are not really, able to produce premium quality products or premium quality parts. Okay. So the requirement here is, I want to re-engineer this process. And let me choose another color. And I want my process to operate like this. Are you seeing my process now? Tell me, all of you. Do you see a new bell curve?
Yes, sir.
Yes, sir.
The bell curve, the complete bell curve is operating within, the premium range. That means what is the difference between this process and the old process? The old process average is for 40. This new process average will also be 40. Then what is the difference? The spread of the process is narrower. Can you see that now? The spread is very, very narrow. Are you getting it? Are you seeing it?
Yes, sir.
Yes, sir.
The first process, the spread is very, very, wide. And the formula is 6S1, where S1 is nothing but standard deviation of the data you have collected. The second process, the spread is, very, very narrower. Here it is 6S2. Now the logic is your S2 is very less than S1. Are you getting it? Your S2 is very less. That means you need to run a process which is far better, far more consistent than the previous one. At the same time, it should operate around the target. This is very, very simple. This logic is very simple. Just imagine you have a parking area. This is your parking area. And you got a car. Now, what am I suggesting is your car must be smaller than the parking area. Your car must be smaller than the parking area, and you have to park your car in the safest area in the parking area. Yes or no? Is it the safest area? Yes or no?
Yes, sir.
Yes.
Similar logic is applicable for your part dimensions also, part characteristics also. Why am I saying this as safe area? Because I have plenty of excess tolerance available here, plenty of excess tolerance available here also. Whenever you have a car which is smaller than the parking area, the process is capable. Suppose if the reverse is the scenario, your car is bigger than the parking area. Can you make a safe parking? Not possible, impossible. The process, no, definitely the process is bound to fail. Right? And this is what you need to understand and focus on, improving your CPCP game. Thereby, you can expect a better field life. And moreover, please understand each and not only a particular thickness can lead to the field life. Similarly, there are many critical characteristics involved. You need to improve the CPCPK of all those characteristics. Thereby, your products, as a whole, can perform better in the field and will have a longer life as well. Yes, Arun, you want to ask something?
Yes, sir. Since we are, or if we are creating a premium quality, it will also have impact on the cost, right? The cost
Very
of
good, very good,
the
very good.
equipments or whatever we are using to produce that, it will be a lot. So
See,
how do we?
yeah, it's a situation of quality versus cost. Now you have to take a call. You have to take a call, right? Sometimes we give more importance to the quality than cost. Is my statement correct? Particularly in the initial stages of product development, we have to give more focus on the quality. Yes or no? Let's say you started a new
Yes,
business. Do you want to be immediately profitable from day one?
yes, yeah, that's right. Yes, sir.
So see, some compromises and trade-off are required. So the priorities matter. If your company is really facing serious quality issues, you
Mm,
shouldn't be talking about the cost, and you will not be able to, then fix the issue. If a field failure happened, what else you want to, see to improve on your quality, isn't it? Field failure can cost much bigger money. Yes or no?
yes, yes, right.
If your vehicle fails in the field, and if that is, the message reaches, all your target audience, then nobody is going to buy your, product. So it's very, very important that, we shouldn't be, thinking in terms of cost, certain occasions. So we have to see, it's like, constructing a bridge. I know when I have to construct a bridge, this will, complicate the traffic further, too high. 10 times traffic will increase. But I also know that when I actually complete the construction, it will smoothen the traffic, in a much better manner. Yes or no?
Right, yes, sir.
So this approach is required if the focus and priority is quality, right? Until that point of time, you will know the companies may not even think in terms of CPCPK. They may just consider CPCPK as a formality and some kind of documentation requirement. No, it shouldn't
Okay,
be. Okay, point
okay,
number
okay.
one. And
Maybe I had this question because I'm working in new product development. Most
yes,
probably we will be proactively thinking for how to deal with these scenarios. That's why, if I am making my product for high quality, then I'm incurring more cost in the beginning only. So is there anything different I need to consider for new product development, or is it the similar
yeah,
approach?
yeah, definitely, definitely. See, I am talking about a single product characteristics right now.
Mm,
But single product characteristics can also become a reason for a complete product failure. Yes or no?
yes, sir.
Your entire vehicle engine can cheese. because of poor dimensional characteristics of a piston. So
Right.
if you are in a product development, yes, definitely no. The what do you call you see if your concern is field failure, if your concern is the life of the product, then you must necessarily think in terms of the capability. Don't just try to run the show through 100% inspection. That shouldn't be the goal. 100% inspection cannot assure quality. 100% inspection can only assure you can eliminate the defective part. But what needs to be done is you should in fact stop the occurrence of the defective part. That is what is the quality improvement. Are you getting my point? What is
Yes, sir.
required? The occurrence, not just simply reworking is a kind of containment you are doing. You are not actually solving.
Mm.
There is a difference between containment and corrective action. Corrective action is you have to improve the process. And containment is you can do rework, you can do 100% inspection, and all these things are just correction. Hope you
Right. Yes.
get the
Yeah.
point.
Yes, yes, sir. Yeah. Thank you.
Yeah. So, okay, I think all of you are seeing my screen. See, this is one thing. See, I'm just telling you, if you are thinking in terms of warranty, you are thinking in terms of the field failure. You are thinking in terms of providing premium quality products or premium quality products, quality services to your customers. Then one option is identify critical characteristics, particularly quality characteristics. Critical quality characteristics. We call it what? DD, right? Then maintain higher capability. Higher capability in the sense CPK. Another, in case you are not able to think in terms of the CPCPK, another method is what is this? Accelerated life testing. Accelerated life testing, the sometimes the OEMs they do a durability study, the test, isn't it? They run the engine for continuously several thousand kilometers and check whether a failure happens or not. In a way, if your engine easily pass through your durability test, it simply means you already maintained what? A good CPCPK, isn't it? Are you getting my point, all of you?
Yes, sir.
Okay, so CPCPK study is should be part of your the initial quality planning, and so thereby quality is assured to your customer. And another option, if you do not have CPCPK in place, but still you wanted to ensure the field life and everything is in place, then you have to focus on accelerated life testing. If accelerated life testing doesn't gives you a poor life, then probably you have to come back and focus on all critical parameters only. Good. So the CPCPK, in order to calculate the CPCPK, these inputs are required. The target is required, upper spec is required, lower spec is required. Now, from the process, collect data from the process. Collect data from the process, then you calculate process mean and process standard deviation. Are you comfortable with all these terminologies, all of you? You have been taught already, right?
Yes, sir.
Yeah, very good. Process mean. Process mean is X bar. Now I'm going to give symbol to customer target as well. Customer target, this is customer target. Customer target is mu. I don't have the symbol, so I'm just typing like this. Now, are you with me, all of you? There is mu, there is X bar, there is upper spec, lower spec, there is standard deviation. Clear? Now, let me visualize. What is this? Target. Now, what is this? Upper spec. And this side, lower spec. Now you got an average, process average. You got a process average, you got a standard deviation. Now tell me, any process will have a spread of how much? 6 times standard deviation, yes or no?
Yes.
Any process will have a standard deviation 6 times. Now you
Yes.
have to check, how is, your process with respect to the customer requirement. Customer requirement is already visualized. There is target shown, there is upper spec shown, there is lower spec shown. Now your process can be described with the help of a bell curve. Do you agree, all of you? I can
Yes.
describe my whole process just by using, two statistics, two characteristics. One is mean, another one is standard deviation. Because if I know the mean, if I know the standard deviation, I can draw the complete bell curve. Now I am going to draw the bell curve, for my process. Now let me say the X bar. X bar is 40 mm. This is an excellent scenario because customer target is how much? Customer target is 40.
40 mm.
40 plus minus 0.5.
Process average is also 40. That means your process is centered properly. Yes or no?
Yes.
That
Yes.
means your process is centered properly. I don't see any problem with the center of the process. The process is centered correctly. Point number one. So this, yeah. So let me now bring in the, pink color. Okay. My X bar is here. And standard deviation, sample standard deviation, I use the symbol. Customer has given a tolerance of 0.15. And now let me say 0.5. Let me say my standard deviation is 0.166. That means my process is experiencing a very less variation. Standard deviation is very, very small, 0.166. Now please tell me, what will be 3 times standard deviation? Nobody is able to
0.5.
calculate this.
0.5.
0.5. So that means this is how my process is going to perform. And here is the x-axis. Now you see this line, the lower spec becomes lower control limit. The upper spec becomes what? Upper control limit. Now please tell me, how many standard deviations will get accommodated between upper spec and lower spec?
6.
6.
6 standard deviation. And what will be the percentage of area that will be covered, inside control limit? We very well know
99.
99.7. So this is the situation. In this situation, if you produce 10,000 parts, your process has a natural ability to produce at least 997 parts within the specification. Are you getting my point? If you produce 10,000 parts, your process has a natural ability to produce at least 9,900 and 10,000, no? 9,973, sorry. 9,973 parts will certainly be within the spec. Are you able to relate this, all of you?
Yes, sir.
Yes, sir. Yeah.
This is the situation known as CP/CPK equal to 1. This is the situation known as CP/CPK equal to 1. What did you see under this condition CP/CPK equal to 1? Your control limit Overlap with
And
what?
specification limit.
Very good. If your control limit overlap with specification limit, and if the process mean is overlapping with the target, in that situation, your CP will be equal to CPK and both will be equal to 1. Clear, all of you? This is called just capable scenario. This is called just capable scenario. And now at this time, at this situation of the CPK of 1, I write sigma level. The sigma level will be equal to 3. Sigma level will be equal to 3. What I simply did, I multiplied the CPK by 3. What is the sigma level now? 3. If the process is operating at sigma level 3, what is the yield you can expect? First pass yield? What is the first pass yield you can expect?
99.73.
99.53%.
So logically understood, right? This is based on the property of normal distribution. So that is why we want to go capability higher than 3 sigma capability. That is why the industry norm for CPCPK is CPK should be at least 1.67. And even your CP should also be at least 1.67. If the characteristics you deal is critical, high critical. If it is less critical, then CPCPK can be 1.33. Do you understand, all of you? And who gave this guideline? AIAG. What is AIAG? Automotive.
Industry Action Groups.
Very good. Automotive Industry Action Group. Now, all of you tell me, if you are earning a salary of 2 lakhs a month, right? And all your EMI, your monthly expense and everything, when I sum up, and that is also 2 lakh. Are you happy now? 10th of every month, you are getting 2 lakhs
No.
credited. And the same day, all the EMI and everything, is paid, and your balance is now 0.
No, not
Is
happy.
it okay for you?
No, it's not okay.
Definitely not okay. So, a CPK of 1 is definitely not okay. And graphically, it looks, everything is good there. But practically, it is not good. Do you all agree? Very important. So, that is why the guideline says a CPK of 1.67. Now, how can I improve the CPK? Now, I need to check on my X bar. I need to check on my S. I need to check, what is this? I need to check on my X bar as well as I need to check on my S. Yeah. One is X bar, the other one is S. Now tell me, what should I check with X bar and what should I check with S?
Average is 6%.
If X bar aligns with the mean and S is lesser than process.
X bar should align or overlap
Mean.
with customer target. This is what you should check.
Yes.
If your mean is more than the customer target, then your process is shifted rightwards. If the mean is less than the customer target, that means your process got shifted leftwards.
Good. Yeah.
So please understand your process is experiencing a shift whenever X bar is not equal to target. Am I correct? Yes or no?
Yes.
At this condition, CP will not be equal to CP. At this condition, CP will not be equal to CPK. So this is the significance of getting your process average right on target.
So
Getting
please
your
repeat,
process
sir.
average
This
right on
process
target.
shift
Yes, sir.
whenever
Are you asking a question? No, you are on mute.
so this process shift whenever X bar is not equal to target. Please explain once again.
See, whenever X bar is not equal to target, we need to understand our process has got shifted either to the
Shifted.
right side or to the left side.
Okay.
If you understand X bar is more than the target, then shift is on the right side. Then your bell curve is skewed right side.
Okay.
And similarly, if your X bar is smaller than the target, then you can understand your process got shifted leftwards.
Okay.
Means it
So
should be within the limit.
you can understand whether your process got shifted or not just by comparing the value of CP and CPK. The expectation is both should be equal. Expectation is both should be equal and both of them should be more than 1.67. Clear? Another thing is S refers to standard deviation. Standard deviation, the meaning of standard deviation is deviation from the mean value. Already we ensured that mean is on the target. Now, if the other data points are moving away from the mean, it is actually moving away from the target, right? So the standard deviation is smaller the better. Yes or no?
Okay.
Smaller the
Yes, sir.
better.
Yep. Yeah.
So if you make it smaller and smaller, the process will become more and more consistent and more stable. How can this happen? Through effective standardization technique. Yes or no? Through effective standardization technique, or wherever possible, try to automate, because the manual elements will obviously cause more variation. So wherever there is a possibility that you could automate certain tasks, or you can better standardize, all these efforts you can put in and to bring down the standard deviation. Now just assume your standard deviation is reduced to half of it. Earlier it was 0.166, right? Half of 0.166 is how much? 0.08.
Right.
Okay. Now the standard deviation is reduced to 0.08. Now how the same process will look like? Let us understand. Okay. There is target, there is lower spec, and there is upper spec, right? So I write here upper spec, target, and lower spec. And target is 40, and this is 40.5, and this is 39.5. Now my X bar. Now what is the condition? X bar 40 means, is your target and process average overlapping?
Yes.
That means there is no shift. And
Yes.
now we know our standard deviation is 0.08. Now your bell curve will look like this. Are you seeing it? Your bell curve will look like this, and this is your x-axis. Now your control limit is far inside the specification limit. Are you seeing it, all of you?
Yes, sir.
Yes, sir.
Your control limit is far inside the specification limit. See, in the old scenario, the tolerance given by the customer, the entire tolerance, distance between LS and USL, was fully occupied by your process. Have you noticed earlier? When CPCPK was 1, the entire tolerance was consumed. Like, the whole salary was, consumed on the 10th of every month. Because your salary and expenditures are equal. But now this is not the case. Only half of the tolerance is consumed. Can you see that, all of you? And right now, since the standard deviation is half of the original thing, now this will consume only 50% of the tolerance. Are you getting my point, all of you?
Yes, sir. Yeah.
So in this condition, if you calculate your CP and CPK, first of all, they will be equal. Why are they equal? Because your process
Mean
is
is
not
same.
shifted. Mean is on the target. And you will get double the value. When you consume 100% of the tolerance, your CP/CPK is 1. When you consume 50% of the tolerance, that is, half of the tolerance, your CP/CPK becomes what? 2. If you consume 1/3 of the tolerance, your CP/CPK will be what? 3.
3.
So CP/CPK of 1, CP/CPK of 2, and CP/CPK of 3. Do you understand all the three scenarios?
Yes, sir.
CPK of 1 refers to a just capable scenario. CP/CPK of 2 refers to a doubly capable scenario. CPK of 3 refers to triply capable scenario. When CPK is 1, sigma level is 3. When CPK is 2, sigma level is 6. When CPK is 3, sigma level is 9. This is the relationship between CPK and sigma level. All of you, do you understand this? Now I'm going to reveal the formula of CP and CPK. Any questions so far? All good?
Sir, I have one question, sir. Sir,
Please.
if the customer target is minimum 2 mm, if they are given a one side tolerance, so in
Correct, I
that
understand.
case, what can we do, sir?
I got your question. If customer tolerance is only one-sided, then you just have to calculate only CPK. CP is not required.
Thanks.
Only CPK is required and CP is not required. Okay, done. So now I'm going to reveal the formula. CP is equal to customer provided tolerance divided by process spread. What is customer provided tolerance? USL minus LSL divided by 6 times S. What is S? The process standard deviation. What is S? The process standard deviation. Customer tolerance divided by process spread. Okay. And now, please understand, this is similar to comparing the parking area and the car. If your car is smaller than the parking area, yes, there is a greater chance that you can park the car safely. Yes or no? But
Yes, sir.
Yes, sir.
if the driver do not know how to drive a car, even though your car is smaller, still it can lead to some unsafe events. Yes or no? So you just because your CP is okay, you should not say no, everything is capable. So CP, that's why CP is named like this. CP is named as potential process capability ratio. It is telling you there is a chance, that's all. Then what can you say? You can say your process is consistent. Definitely you can say consistent. There is no problem with the consistency, but then you cannot say it is capable. But you can definitely use the word potentially capable. So that's why CP is known as potential process capability ratio. Then how do I calculate CPK? CPK is minimum of CP upper, CP lower. What is CP upper and CP lower? I'll tell you. And see, if process is shifted right, then CPK will be equal to CP upper. Do you understand, all of you? If your process is shifted left, then CPK will be equal to CP lower. You can use any logic. You can use this logic. CPK is equal to minimum of CP upper and CP lower, or otherwise, if process is shifted right, consider CPK as the CP upper. If process is shifted left side, consider CPK as CP lower. Now, what is the CP upper? I'll give you the form. CP upper is a ratio. USL minus process average, which is X bar, divided by 3 standard deviation. CP lower is another ratio. X bar minus LSL divided by 3 standard deviation. See, if you look at the formula of CP upper and CP lower, if there is no shift, both ratio will have the same value. If there is no shift, both ratio will have same value. How many of you are able to visualize USL and USL minus X bar? Can you tell me, can you tell me another suitable terminology for this? What is USL minus X bar? Is it representing the full tolerance or half tolerance?
Half tolerance.
Half tolerance on the right side divided by 3 standard deviation is half spread on the right side. Are you with me? Half tolerance on the right, half spread on the right. Similarly, half tolerance on the left, half spread on the left. If your process is perfectly centered and the spread what you have on the right side, spread what you have on the left side, because bell curve is symmetrical, will be equal, and your CP upper and CP lower will be equal. But the moment your process is shifting, if it is shifting right side, CP upper will get reduced because your X bar is, your X bar is moving to the right. So the distance between USL and X bar will reduce. Can you understand that? And so the whichever side the value is going down, that will be assigned to CPK. CPK will be equal to, that is why the formula minimum of CP upper, comma, CP lower. So this is the theory behind the process capability analysis, CP and CPK value. And the requirement is 1.67 for critical characteristics and 1.33 for non-critical characteristics. But in any case, maintaining a higher value is always good. Do you understand so far, or do you have any questions to ask? Please tell me.
Sir, for this one-sided tolerance, you
Hmm.
mentioned we should consider only CPK, right?
Yes.
Uh,
You don't need to look at the CP. It will be, it will lose its value. But CPK is important, even for one-sided tolerance.
so how it will be considered upper specification, lower specification?
See, if you understand, you can, decide everything and then, directly go to CP upper or CP lower. But otherwise, another method is you calculate both CP upper and CP lower. You calculate both. But after calculation, whichever has a lower value, that should be assigned to your CPK. Do you understand? Now I will show some slides, and I think that will, help you understand furthermore better. Please confirm, are you seeing my screen?
Yes, sir.
Yeah.
Let's see.
Look at the formula. CP is USL minus LSL by 6 standard deviation. CP upper USL minus X bar by 3S. X bar minus LSL by 3S. Minimum of CP upper and CP lower. This is what I taught you. This is potential process capability ratio. This is process capability index. Now look at the graph and tell me, is this process capable or not? Are you seeing the control limit inside the spec or outside the spec?
Inside the spec.
They're not answering, simple questions. At least one or two should take the responsibility and answer. So the control limit is inside the specs, so the process is capable. Now, and moreover, look at the process as center, process average. Is this process average centered on target? Yes.
Yes.
So in this case, CP will be equal to CPK. Look at the tolerance given by the customer, 20. Look at the spread of your process, 12. 20 by 12, check how much it is, 20 by 12. 1.66 or 1.67. The requirement is met. Now what happens? This process got shifted. Can you see all of you? How the process is shifting? The process got shifted. When the process shifts, what will happen? The X bar will no more be on the target. It is no more 40. It is something else. Am I correct or not?
Yes.
Yes, sir.
But even in this situation, if you calculate CP, it will still be 20 by 12. Can you see here? It will still be 20 by 12. It will still be 1.67. But your process has started producing rejections. You see, your curve has crossed the USL, and this area refers to the defective parts. So what am I supposed to do? I have to introduce another metric, not in addition to CP, to check whether my process got shifted or not. For that, I break the tolerance into two. Customer given me a full tolerance. So half of the tolerance on the right side. What is half the tolerance on the right side? USL minus X bar. Can you see the blue color portion?
Yes, sir.
Yes, sir.
Other of the tolerance on the left side is X bar minus LSL. Similarly, the spread also divided 3 sigma, 3 sigma. The right side ratio USL minus X bar by 3 sigma. This is CP upper. The left side ratio X bar minus LSL by 3 sigma. This is CP lower. Now, if my process shift to the right side, which will reduce? The blue bar will reduce. If my
Yes.
process shift to left side, the green bar will reduce. If blue bar reduces, CPR will go down. If green bar reduces, CP lower will go down. Whichever side value is going down, that side, my process will start producing rejections. So that whichever side my process is shifting, that side, the CP upper or CP, if it is right side, CP upper will be assigned to CPK. If it shifts leftward, CP lower will be assigned to CPK. Clear, all of you? Now
Yes,
you
sir.
see, now which one will be assigned to CPK? CPK will now be equal to what? CP
CP
upper.
upper.
Very simple. So the message to all of you here is, don't just judge, the safety of the parking just by looking at the parking area and the car. In addition to the size of the car, driving skill is also important. Yes or no? You have to drive carefully at the center of the parking area, and then park your car. So whether that driving skill is there or not, and that is what we are checking with the X bar. Now this process is shifted, and in this condition, you can calculate the CPK and check whether you are able to meet the standard 1.67. So now, whenever CP is found to be equal to CPK, you can understand your process is centered properly, right? Your process is centered properly, no shift. No shift. But if CP is not equal to CPK, what does it infer? The process got shifted. So you have to move the mean closer to the target. You do something at your process so that the statistical mean can move closer to the target. And CPK, if it is more than 1.67, if the condition is satisfied, process is capable as well as consistent. But if this condition is not satisfied, your process is not capable, but still may be consistent. All right. Now let's take a simple example. Let us take this example. An electronic manufacturing process. The specification for current flow is 100 plus or minus 10 milliampere. Tell me what is the target here?
100.
Very good. Target is 100.
100.
Where is it written? Target is 100. And USL is 110. LSL is 90. And the process average is 107. If the process average is 107, your process is shifted or not?
Yes, sir.
Shifted.
Shifted towards right.
Shifted rightwards. Now your CPK will be what? CP upper.
Yes.
Your
Yes.
CPK will be CP upper. You see your CP upper is 0.66 and that is assigned to CPK. So now let us calculate. CP is specification width, nothing but customer tolerance divided by process spread, which is USL minus LSL divided by 6 sigma or 6S. Now according to that, you are getting a CP value of 2.22. Now what is your conclusion? Your process is capable or not?
Yes, sir. Very much capable.
No, you
Consistent.
should not say like that. Your process is
No,
consistent.
process is not
Or you,
capable.
or you can say your process is potentially capable.
Mhm.
In order to check the exact capability, you have to calculate CPK. Formula is CP upper and CP lower, and you know the formula, and I substitute all the formula. CP upper is 0.66, CP lower is 3.77. Since it is shifted right side, and and moreover the minimum of the two is 0.66, so my CPK is 0.66. That means it is highly unacceptable.
Here we
CPK
can
of
understand
0.66 is
this process consistency is there, but it has shifted with the consistency. That's what we can. Variation is less.
yes,
Once the center
consistency
is
is
not met.
there. Consistency is there, but but capability is not there.
Yes.
Somebody writes an exam 10 times, and all 10 times, he got, less marks. All 10 times single digit only. Can you see a consistency?
Yes.
Yes.
Yes. But all are fail mark, and so there is no capability. That is what is happening here. So you have to, the consistency is appreciated, but at the same time, we want the candidate to always score, good marks. So you have to improve on the CPK, which means you have to move the mean. The mean is now on the bad side. Now pull back the mean, bring it closer to the target so that your process will start delivering the needed result. All of you, do you understand this?
Yes, sir.
Yes, sir.
And you can apply this knowledge, wherever required, but the condition is measurable characteristics. Another example, extrusion die, aluminum rod. The diameter of the rod is CTQ. Specification on the rod is 5035 plus or minus 0.0010 inch. That means the target is here 5035, upper spec is 5045, lower spec is 5025.
5.
All those values are written here. You see, USL, LSL, X bar, and X bar is 0.5031. Now tell me, 0.5031, is it exactly on the target or shifted leftward or shifted rightward?
Shifted towards
Left,
left.
sir.
So CP lower, you have to calculate CP lower. You see, CP lower is 0.66. That CP lower is assigned to CPK. Now tell me, your CP is 1.11. Your CP itself is unacceptable. Process is not consistent. So you have to further reduce the variation. You see, you have to reduce the variation. And CPK is unacceptable. In addition to reducing variation, you have to move the mean closer to target. Do you understand, all of you? Move the mean closer to target. There are two, see, what we are telling is statistical suggestions. But how they will reduce variation? Through standardization, training their employee, adopting, some better approaches. So variation will come down. If they adhere to the standards, adhere to the procedure, then mean will not shift. Are you getting it, all of you? Now tell me, for a process, CP equal to 0.94, CPK equal to 0.33, and the process is not capable, what action is needed? Tell me, all of you, what action is needed?
Action to be taken, sir. Process to be consistent and also to be centered.
We need to
Ah,
bring mean
yes,
closer to target.
very good. I like this statement. Move the mean closer to the target. Move the mean closer to the target. And then the process is inconsistent. So what should I do? I should reduce the variation. I should reduce the variation. Your sugar levels are highly inconsistent. Now, what are you supposed to do now? You should follow your diet chart. Yes or no?
Yes, sir.
Yes.
Sir, one special case
Yeah.
in reality, process like that extrusion die casting, some
Mm.
pressing tools.
Mm-hmm.
So the output part will be maintained initially at the lowest stage, so that over usage, it will uh, compulsorily move to the higher side, and it will utilizes the tool life for a longer time. In that case, if you maintain that mean, then it's not economical. I am telling about the special case, not about machining and
Yeah,
all.
I
You
understand.
getting
See,
my
there
point,
are
sir?
special, see, what we want, we want all of you to, gain the wisdom from here and then use it to support the situation.
Correct.
You should not use any theory, a bit blindly. There is no use.
Correct.
Like there were situations about one-sided tolerance. There were, it can be upper spec important sometimes, lower spec important sometimes. Sometimes, for some valid reasons, you want your process to operate in a particular range only.
Correct. Extrusion center will come under that category. Initially,
Very good.
over a period of time, it definitely will gradually it increase, so that we'll intentionally maintain the lower side.
Correct.
This
So that
special
means
case
you are
is
you
not
are
for
considering the
all.
long-term performance in the initial stage itself. You want your process to remain capable for a longer time, and
Correct.
you are doing that, adjustment. That's correct. Sometimes staying at the center is always safe, but sometimes, for some valid reasons, yes, you push your process to
Correct.
the required side. See, that's
Thank
what
you.
I want all of you to understand the tool concept and then use it wisely in your field, in the situation. All these tools will enable you to think wisely and then make decisions wisely. Okay. And as I told you, the service industries,
Sir,
they
sorry,
can,
sir, your screen is not visible.
no, no, I stopped. I
Oh,
stopped.
okay, okay, okay.
So the service industry, they can use the tool to have good control over, the turnaround time, processing time, loan processing time, PO release time, In all those areas, they can maintain CPCPK, but there must be a necessity. There must be a necessity. Just because don't just go for a CPCPK requirements, everywhere. But if some repeated failures are happening, and if there is a compelling reason to improve with respect to a particular characteristics, let us say in BPO industries, the service level agreement SLA has to be minimum 95%, minimum 98%. So, and you wanted to have better control over, fulfilling the SLA, then you can think of using it. And so that's how it is. So, any specific questions to me? Tell me, all of you, any specific questions? Or you have understood?
No questions, sir.
Then in that case, I will just show one more simple method of conducting this CPCPK analysis, because manually calculating is sometimes difficult for all of us. So let me show you how can you handle the CPCPK analysis very easily. So now I will share my screen. We'll use some data. So I just share my screen. So let me go to, where is the data? This is the data I want. What is the parameter? The characteristics is coating thickness. The coating thickness requirement is 50 microns. Requirement is 50 microns. Tolerance is plus or minus 3 microns. And see here, 25 times samples are taken. How many times? 25 times samples are taken. Each time there are 3 samples. Now I am going to Minitab. I place this information, the data points here in the Minitab. Are you seeing, all of you? Coating thickness is in column 1. The roll number is in column 2. How many times samples are taken?
25 times.
25 times. And every time we have taken 3 samples. All of you, I am giving another important input. For CPK calculation, samples must be collected in subgroup. Must be collected in subgroup. In this case, how many subgroup? 25.
3
Number of subgroup is 25.
25%.
And subgroup size is how much?
3.
3. This is what is also called as sample size. You have to plan, your data collection, spread your data collection, in a proper way, so that you can get a realistic CPCPK value. And between your, every sample or every group, there must be a time gap. You shouldn't be collecting, all the samples, continuously. If you collect all the samples continuously, then you will not be able to calculate CPCPK. So these are requirements. Please keep it in mind. And now that's how, 25 subgroup, each subgroup having, 3 samples, the data is recorded. And now the target is how much? 50 microns. Upper spec will be 53 microns. Lower spec will be 47 microns. Now let's see whether, according to this data, let's see our process is capable or not. With the Minitab, the job becomes much easier. Go to stat, go to quality tools, go to capability analysis, preferably go to capability 6-pack. Go to normal. Now where is your data? Single column data. Coating thickness is the characteristics. What is your sample size? You can directly type 3, or you can feed this roll number. Minitab automatically will understand. Now, very important, the lower spec is 47. Upper spec is 53. Are you with me, all of you? How did I do all this? Should I do it one more time? I do it one more time. Stat, quality tools, capability 6-pack. I'll tell you what is 6-pack. And then come to normal.
Normal.
Now, single column, coating thickness, subgroup size, roll number. lower spec 47, upper spec 53. Now Minitab will automatically plot the needed graphs for you. This is the capability analysis report. And first you look at CP/CPK. Look at your CP. How much it is?
2.46.
2.46. CPK 2.37. That means
37.
excellent for short term. Now you should know what is short term. Short term means you just wanted to produce a small batch size. Let's say you want to produce 300 or 3,000 pieces, and it's a small order. Now CP/CPK is good. Now you can run the process and then complete the entire order processing. There is no problem at all. Your PPM, expected PPM is how much? You see here?
Yeah, 0.
You're a little bit zoomed, sir.
No, yeah,
Zero, sir.
expected. Yeah. Yes. Expected PPM is 0. Are you seeing it?
0.
Yes.
But the same process, if you use it for a long-term application when your customer wants a continuous supply, every day 5,000 pieces, non-stop. And now you, in addition to CP/CPK, you need to think in terms of PP/PPK also, because your requirement has now become what? Long term. So what is this PP/PPK? How to do the calculation? And luckily, you don't have to study separately. With the same data, you can calculate PP/PPK. I'll tell you on that little later when we come to the same topic one more time. And now look here. This confirms that your data is normal. And this is the histogram, one of the 7 basic QC tool. This is what I'm trying to draw all the time, with my hand on the screen. You see, the process right now is operating in a dotted line manner. Its spread is coming up to here. But in the long run, the same process is expected to have a higher variation. And this is, this refers to the long-term performance of your process, whereas the dotted line refers to the short-term performance of the process. Now the histogram is actually, showing the spread of the data. And this is individual value plot. This is R chart. This is X bar chart. But one problem I see here is, the control chart gives lot of, out of control signals. Always when control chart gives out of control signals, this shouldn't be ignored. This must be attended to so that the CP/CPK will become valid. If I do not attend to it and don't accept them as special causes, don't take any actions, then the process might, then CP/CPK might become invalid. So this is how you can simplify the job of, capability study using Minitab. Is that clear to all of you?
Sir,
So one
question.
question.
Yes.
So regarding this, how do you say from the graph whether this process is capable for short term or not for long term?
Your question is how to understand whether the process is good for short term or long term, right?
Yes.
The CP/CPK is always a short term capability.
Okay.
PP/PPK are the long term capability. Okay.
Okay.
And the definition of short term and definition of long term, we have to write down after knowing the product, after knowing the characteristics, after knowing the customer demand, and all the facts presented to you. Then we can also write a definition of what is short term and what is long term. So the ultimate goal is your CP/CPK and PP/PPK must be close to each other, so that you can use the process for short term application as well as long term application.
Okay.
Okay.
Sir,
Clear?
one question. On what basis is the Minitab showing that on the long-term process, the PP/PVK value will be lower? Is it based on the
Yeah.
X bar chart?
No. There is a calculation available that I want to explain, later, because everything, same time you might
Noted, sir.
find it, difficult to understand. So I will again come back and then, clarify the CPK. But right now, yes, the CP/CPK is PP/PPK is unacceptable, but CP/CPK is acceptable. That means this process, as far as the short-term application, there is no issue.
Noted, sir.
Good. We'll take a short break here, right? And continue exactly after 15 minutes. And then we'll switch to the hypothesis testing. Is that fine?
Yes, sir.
Yes, sir.
It's okay.
Yeah. Thank you. Let's
Yeah.
have a break. Yeah, have you already understood the topic scheduled for the day, all of you? One is process capability analysis, another one is hypothesis testing, right?
Yes, sir.
So when I see, the what do you call it? I'm not seeing the enthusiasm, for learning, and that too while dealing with a very important topic of the, program. You have to, you know, you must try to participate, and rather I'm seeing all of hiding yourself, and that's not a good sign. I do not know whether the CPCPK also, whether I cannot, stay, fully motivated and then talk to myself. And I can simply play my video in such a situation. I don't have to physically, explain everything. And I need interaction. I've been insisting, regularly, but I do not know why you're not participating. Okay, so now another challenging topic is hypothesis testing that has been already explained to you. I think Dr. Ravi Kumar has explained it. I'll tell you, hypothesis testing in the context of root cause analysis, I am going to help you. Please understand, hypothesis testing is a decision-making procedure, a statistical procedure to make effective decisions, right? Particularly when you make a decision about a root cause, we are going to use the hypothesis test. Now, what decision you make about hypothesis testing? The factor under suspect, can be a root cause or maybe a root cause or may not be a root cause. There are two contradictory statements. One is the factor under suspect is a root cause. What is the opposite statement? The factor under
Not a
suspect
root cause.
is not a root cause. Now, out of the two statements, can you please figure out the statement that can be called as a null hypothesis? Which is null here?
Not a root cause.
Very good. Not a root cause. The factor under suspect is not a root cause. So, null hypothesis is always a statement of innocence. Is always a statement of innocence. The opposite is alternate hypothesis. For null hypothesis, we normally use a symbol H naught. H suffix naught. For alternate hypothesis, we use a symbol H suffix A or H suffix 1, H1. Okay? And what are the other way of defining null hypothesis? Null hypothesis is always a statement of statement of equality. Null hypothesis is always a statement of equality. Let's say a solution has reduced the rejection. Your corrective action has reduced the rejection. Now you wanted to prove, the solution is effective before and after. So the rejection rate before is equal to rejection rate after. Now what kind of statement it is? Again, null. In this scenario, it is a statement of equality. But if you want to prove that your solution is effective, then you have to prove the before rejection is not equal to after rejection. In fact, after rejection is smaller than before
Smarter
rejection.
than before.
This is called alternate hypothesis. So, null hypothesis can be a statement of innocence, can be a statement of equality, can be a statement of no impact, whether temperature affects the efficiency. Now there are two possibilities. Yes, temperature affects the efficiency. Another one is temperature, doesn't affect the efficiency. And now which actually leads to a no impact statement? The temperature doesn't affect the efficiency. So that should be called as null hypothesis. So the opposite one, temperature has an effect on the efficiency. That is called alternate hypothesis. So null hypothesis is a statement of innocence, statement of equality, and statement of no impact. Please remember this. And this is the first step in hypothesis testing. You have to do it right. If the first step goes wrong, your decision will certainly go wrong. Clear, all of you? Step number one. Let me put this, in some writing. I'm sharing my complete screen. That's going to mini tab. Just session area. Okay. So H naught means null hypothesis, right? Which is statement of innocence, statement of equality, and statement of no impact. Or otherwise, you can say factor is not a root cause. Hope you all understand this. And H1 or HA, this is alternate. Just the opposite. Alternate hypothesis. Now just put the opposite. It's a statement of guilt, statement of inequality, it's a statement of impact, and factor is a root cause. Are you with me, all of you? This is your step number 1 in hypothesis testing. Is it clear?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Step number 2. Step number 2 is fixed level of significance called alpha. Normally it is 5%, which also means we want to work with the confidence level of 95%. Confidence level of 95%. Confidence level is 1 minus alpha. If alpha is 0.05, 1 minus 0.05 will be 95%, right? And what is this level of significance? The level of significance refers to permissible risk of random chance. No, random chance generating the data. Do you understand, all of you? Do you understand the meaning, or this has been already taught you? If you already know it, some better way, you can let me know. Level of significance refers to permissible risk of random chance generating the data, or uh, it refers to the risk of, this is better, refers to the risk of rejecting a true null hypothesis. Which one is easier? Risk of rejecting a true null hypothesis. What is the risk of rejecting true null hypothesis? Risk of rejecting true null hypothesis means you wrongly conclude an innocent factor as root cause. Possible or not? Can you punish an innocent fellow? In
No.
judicial
Yes, sir.
system, in judicial system, 100 criminals can escape, but one innocent should not be punished. Same manner. All the actions you take, whether you take the right actions or not, you should never be taking a wrong action. Right? Whether you make the needed change or not, you should never make an unnecessary change. So the normal, it's an industry practice that they fix, they limit it by saying that the level of significance is 5%. Level of significance 5% means 95% of the time when you no, 95% of the time you shouldn't be rejecting a true null hypothesis, but 5% of the time, okay. That means 100 times when you reject a null hypothesis, 5% of the time, yes, you can reject a true null hypothesis. This is only, standard. It doesn't mean you have to reject. You should ensure the chance of type 1 error is reduced to below 5%. Clear, all of you? Understood?
Yes, sir.
Yes, sir.
See, if you don't understand also, you can ask questions. Or is that discussed in the last week? Yes or no? Is it discussed,
Yes, we can
explained?
discuss.
No, no, sir. Only the
Oh.
basics of alternate and null hypothesis have been briefed.
Null hypothesis, alternate hypothesis, and in hypothesis testing, always you have to make a decision only when the risk associated with your data is reduced to below 5%. If the risk associated is not reduced below 5%, then it's not the right time to use the data and make a conclusion, right? And in another way, rejecting a true null hypothesis is called or known as type 1 error. Is known as type 1 error. Rejecting a true null hypothesis is called type 1 error. So type 1 error is very sensitive. This is what I told you. Whether you make the right change or not, you should never make a wrong stage. No wrong change. Whether you achieve an improvement or not, you shouldn't destroy the existing result. Hope you all understand. Now, step number 3, experimental data. Step number 3 is experimental data. That means you conduct the experiment and generate the data. And prior to that, before conducting the experiment, select the hypothesis test. This also we'll see. You have to select the hypothesis test. And once the hypothesis test is selected, then you have to go step number 4. Step number 4 is conduct the experiment and generate the data. Then step number 5. Calculate the required statistics. Calculate the required statistics and the associated p-value. I'll tell you the significance of p-value. And this first of all called probability of significance. So what is p-value? P-value refers to the probability of rejecting null hypothesis when it is true, or probability of committing a type 1 error. Hope you all understand all the language. Okay. So now once after getting the p-value, then step number 6 is decision rule. What is the decision rule? If p-value is below 5% or below 0.05, then you can reject the null hypothesis. But if p-value is more than 5%, fail to reject the null hypothesis. What does it mean? The meaning. If you reject the null, the factor under the suspect is the root cause. If you fail to reject the null, the factor under suspect is not the root cause. So this is the procedure you must follow for validation of root cause. How many steps are here?
6 steps.
6.
Yes, simply go through the 6 steps, and wherever you have issues, please ask me. I'm here to clarify. Do you understand all the 6 steps? I have put it in the chat box as well.
Vara.
Do you understand all the 6 steps? Or you
Uh,
have any challenges?
Calculation of p-value, sir.
Okay. So p-value is not a calculated value. P-value is a tabulated value. P-value is a
Tabulated.
tabulated value. So you can use Minitab. It will automatically, populate the p-value. You don't have to worry. Or otherwise, you have to refer to various distribution tables available. You have to pick up the value correctly based on the situation from the table. So what I suggest is you please use Minitab or use Excel also. I'm going to teach you today how to use Excel so that you can conduct the hypothesis testing with the Excel itself. Good question. Is there any other question? That's it. Okay. Now let me explain this with a simple example first. Afterwards, we'll go to a technical example. All of you, do you know Virat Kohli?
Yes, sir.
Yes.
Yes.
What is his
Yes,
batting
sir.
average?
Yes,
What is
sir.
his batting average?
98.
Approximately
Close to
approximately
50.
55, right? Close to 50 or 55. So I'm saying that his batting average is 55 plus or minus 5. That means you are expecting him to, you are seeing him, 95% of the time is maintaining his batting average from 50 to 60. Yes or no? All right?
Yes, sir.
Yes.
Yeah. So this 95% is known as the confidence level, which refers to 95% of the tournaments he maintained his batting average in this range. That means 5% of the tournament his batting average is found outside the range we are talking about. Correct?
Yes, sir.
Yeah. The lower limit is called lower confidence limit, which is 50 in this case. The upper limit is called upper confidence limit, which is 60 in this case. You can also put 95% here so that you will know what limit you are talking about. Now that means Kohli is expected to maintain his batting average between 50 to 60. Now Indian Cricket Board, they want to appoint a coach so that his batting performance can improve. Right? Batting performance improvement. For that purpose, the Indian board has decided to appoint a coach. So you know what they did? They appointed a coach from New Zealand. Now coach is appointed. After the coach is appointed, I know the coach will be paid a very big compensation in crores per month. So after 3 months of time, after rigorous coaching and all the practice he has given, Kohli is allowed to play a tournament, and in that tournament, his he played let's say some 5 or 6 matches, and his batting average is found to be 56.5. Now, all of you, please tell me, is the appointment of coach, is the appointment of coach has improved the batting performance of Kohli?
No.
No, sir.
Why are you saying no? Because
Yes.
because you are still seeing the average
Yes.
within the same
50 to
interval. Yes or no?
Yes.
Yes, sir.
Yes.
This 50 to 60 is known as 95% confidence interval. You are seeing your statistics. In this case, the statistics is average. You please see. You please see. They're actually performing a test of average. The average is found to be within the interval only, within the same confidence interval. Even though there is an improvement, the improvement is not significant enough. Are you seeing that?
Yes.
So this is called insignificant. This is called insignificant. Okay. Now, Now what happened? The board has decided no to try with an Australian coach. So the appointment of a New Zealand coach is on hold or terminated. Now the New Zealand Australian coach. Australian coach also gives a rigorous training. Again another 3 months exercise and all that happened. And now Kohli has played another tournament. So this time the batting average is found to be 72. He played 10 matches and the average is found to be how much? 72. Now, what do you think? Do you see a significant improvement?
Yes.
Why are we saying significant now? Because we are seeing our statistics falling outside the expected confidence interval. Yes or no? All of
Yes,
you,
sir.
please note. All of you, please note. When you have a data, you can calculate statistics, whatever you want. Let's say average. You can also find out the expected confidence interval. There are formulas available, and based on that formula only, this 50 to 60 is also arrived. That's why they are called 95% confidence interval. Whenever you see your statistics outside the interval, it is a situation of statistical significance. Whenever you see your statistics inside the interval, it's a situation of statistical insignificance. Are you clear, all of you?
Yes, sir.
Yes, sir.
If there is a situation of statistical significance, that's the time we say p-value is less than 5%. If there is a situation of statistical significance, that's the time we say p-value is, p-value is more than 5%. Are you with me, all of you?
Is there
Yes, sir.
any definite minimum number of data points required to calculate p-value, sir? Or
No, no, no. Depending on your sample size, p-value will certainly be calculated. But the requirement is p-value has to go below 5%. If p-value doesn't go below 5%, then you need to understand this is not the right time to believe your data. Your experiment is not believable, and so decision should not be taken based on the experiment because the associated p-value is more than 5%. But if it goes below 5%, the information coming from the data is reliable. Okay. Now I'll help you better understand this. I'm just drawing the bell curve of Kohli. Now I'm interested in considering only the upper confidence limit. What is the upper confidence limit of Kohli? 60.
60,
Okay. And now let us assume in 95% of the matches, his batting average is found,
50 to 60.
yeah, 50 to 60. And now this left side I want to ignore. I don't want to consider. Now this entire interval I don't want. So now for time being, let us assume 95% of the matches, Kohli has maintained his average below 60. But in 5% of the matches, he is able to maintain 5% of the tournament, he is able to maintain the batting average above 60. Clear?
Either above or below, no, sir?
No, no, that's what I want to ignore this. I just want to work with only one-sided limit
Okay.
now.
Okay.
So I'm just slightly changing the idea now because nobody want to shift the average downward. That is never an idea. So we want to shift the average upward only. So let us assume the upper confidence limit is 60 and there is no lower limit we don't want to calculate. We don't want to consider. So everything under the 60 is covering 95% of the tournament average. But 5% of the tournament average, he maintained the batting average above 60. This is natural capability of Kohli. Are you with me, all of you?
Yes, sir.
Yes, sir.
All right, all right. So now, this Kohli's batting curve, this is 95% upper confidence limit. Okay. Whatever is the confidence limit at the same line in hypothesis testing, we are going to call it line of significance. We are going to call it line of significance. Why? We want to check whether our statistics crosses this line of significance or not. Are you with me, all of you?
Okay, sir.
Yeah.
Now, the left side is 95% and the right side is 5%. Hope you understand this also. The area to the left of my line of significance is 95%. The area to the right of line of significance is 5%. Clear?
Yes, sir.
Now the Kohli's batting average is 55. Now the first New Zealand coach, what was the batting average obtained?
56.
No, 56.5. 56.5 will appear here, am I right?
Yes.
Yes, sir.
Now I'm going to give you the definition of p-value. Definition of p-value is nothing but the area or probability to the right side of your observed statistics. I'll show it, by hatching. The right side of observed statistics. The observed average is how much? 56.5. It goes up to infinity. Now, do you see the hatched area? The hatched area represents what?
P-value.
What is the definition I told you? P-value refers to the area or probability to the right side of the observed statistics. When your study is right-tailed, our study is right-tailed. We are only working with what? Upper limit, yes or no?
Yes, sir.
Now, look at the graph and please tell me, is this probability, which is denoted by the symbol p-value, is this probability can be above 5% or below 5%? Tell me all of you.
More than
Above
5%.
More than 5%.
Very, very good finding because already we understood this small area itself is 5%. But our green color area is touching beyond that, yes or no?
Yes.
So please understand, whenever the calculated statistic is inside the interval, the confidence interval, or inside the line of significance, your p-value will be more than 5%. You correctly told me the New Zealand coach, the appointment of New Zealand coach is insignificant in terms of improvement. Yes or no?
Yes.
Yes.
So insignificant means we are not really able to see any improvement. That improvement of 1.5, whatever we have seen, that cannot be considered statistically. We, this is the time what is that I told you? We fail to reject the null. When p-value is more than 5%, what is the suggestion we have already decided? Fail to reject the null. Are you getting my point?
Yes.
Now,
Fail to reject.
now,
Yes.
now you come here. Now, what is your y variable? Batting average of Kohli is your y variable, right?
Yes.
Batting average of Kohli is y variable. Now, what is the factor you are studying? Coach.
Influence of
Factor you are
coach on
studying?
batting average.
Influence of coach. Yeah, influence of coach on batting average. So the factor is coach. The output is batting average. And now your null hypothesis is coach has no effect on batting average. Then what will be alternate? Coach has significant effect on batting average. And what is the confidence interval you have selected? 95%, right? So alpha is 5%. What is alpha? Level of significance. Alpha is level of significance. That's step number 2 done. So this is step 1. What is this? Step 2. Now what is step 3? The experiment and data, right? I mean, experiment and data. Actually, selection of fiber test. Selection of test. We should actually select a test of averages. We are working with averages, and particularly it is called one sample t-test. I'll tell you why it is one sample t-test, right? And we did the one sample t-test 2 times, one for New Zealand coach, one for Australian coach. Now the step 4. No, sorry. 4, the experimental data. In this case, the tournament played. This case, tournament played is the experimental data. And then the statistics is batting average after the coach is appointed, isn't it? That is the tournament average, I would say. And now, after step number 4, step number 5. Now you have to look at the p-value. I don't want you to look at the p-value very frequently. Please tell me the tournament batting average. The tournament batting average. Is it above the line of significance or below the line of significance? Tell me. For New Zealand coach, for New Zealand coach, it
Below,
is
below.
Below this one.
below. Below means what will be the corresponding p-value?
More than 5%.
So both corresponds to fail to reject null. Fail to reject null means what is your null?
Coach has no effect.
Very good. That means appointment of New Zealand coach is not a good idea. Yes or no?
Yes, sir.
Yes, sir.
Yeah. So decision is practical decision. See, statistical decision is fail to reject. But practical decision is you can hold his appointment, you can terminate his appointment. Yes or no? This is depending on your the leadership. Whatever is best, no, they will decide. But statistics is telling the appointment of the coach is not statistically, significant and not statistically helpful. Are you with me, all of you? Considering Australian coach. Now, what is the tournament average?
77.
77 or 78? 77. Now, my question is this average is greater than line of significance?
No.
Yes.
You have to be very carefully follow. Yes. Because what is your line of significance? 60.
Oh, yes. Okay.
Line of significance is 60. How do we know? This is upper confidence limit. And there are formulas available to find out the upper confidence limit, but I don't want to load you with so many formulas, right? Upper confidence limit is 60, but the what do you call the tournament average is found to be above the line of significance. And in this situation, you already understood the concept. The p-value will be
Less than 5%.
5. So in this situation, what should you do? Now
Reject the
decision.
null.
Very good. Reject the null. That means when it comes to the Australian coach, our assumption of coach having no effect on the influence, no effect on the batting average is actually wrong. So we have to reject the null. If that becomes wrong, we need to accept that yes, coach has a significant effect on the batting average, and that effect is here found to be positive. Yes or no? Because the average shifted from 55 to 77. Are you with me? Now, what is the practical conclusion or practical decision?
Coach has
What is
Keep
effect
the
on.
Australian
Fine.
coach.
Australian coaches
Has effect on.
appointed for 1 year. He's going to enjoy, all the facilities and a big salary. Clear? Do you understand hypothesis testing with a simple example?
Yes, sir.
Yes, sir.
And now, any question, Vikas, you can ask your question.
Sir, can you give another example for the same things, or can you just re-explain this?
And one more thing, during any projects, no, sir, in order to have a good p-value, they say that minimum sample size should be 30 or 20. How do they decide that?
See, not for no good p value. What see always sample higher the better. If you do not have any clue, you can go with the 30 sample size. If you do not have any clue, you can go with the 30 sample size. See, what is our requirement with sampling? We want to take minimum number of samples and still, get a lower p-value. Yes or no?
Yes, sir.
If you are getting a lower p-value, whatever be the number of samples you have taken, that is okay. But if you get the higher p-value, whatever be the number of samples you have taken, that is not okay. Please understand.
Okay.
Sample size estimation is different, no requirement, but we have a solution for that. You see, when I go to stat, can you see what is this option?
Power and sample size.
Here we get solution to your question. But right now, when you are performing hypothesis test, you go for no. See, always no. You will be limited by the no the what do you call the constraints in the real life. Let us say one for to conduct one test. Let us say no, the cost involved is 55,000 rupees. Now, how many tests we can do now?
What is the budget?
Limited. Yeah, I'm telling you 55,000 per test. Now our sample size is now limited by the budget. So in this case, you may go with lesser samples, but still, according to the number of samples you have done, you just check whether the p-value is okay or not. Okay. So Vikas, you have some more question?
Yes, sir. Can you just explain this whole graph thing again, sir?
Oh, whole graph, which one? This there, what you see here,
Yes,
right?
sir.
See, this first of all, please understand, this is the bell curve of Kohli's batting average.
Okay.
For every process, there is a bell curve associated. This bell curve will talk about the natural capability. The natural capability you can describe with the help of the upper confidence limit. Exactly at the upper confidence limit, I have marked the LOS as well, because in this discussion, LOS refers to what? Line of significance. Line of significance should always be drawn on the exactly on the confidence limit only. In this case, we only want to see whether the average is improved or not. That is my question. So I don't want to consider the lower confidence limit. I consider only upper confidence limit. Value wise, this is 60, right? And area wise, 95% on the left side. And the same line is now renamed as line of significance, because I am going to check whether my statistics crosses this line or not. Clear so far?
Okay. Okay.
Now I did a study. I took some samples. That means Kohli played 5 matches. 5 matches, 5 samples, I can calculate an average. 5 matches, 5 data points, I can still calculate an average. All I have to do is whether the calculated average is on the left side of line of significance or on the right side of line of significance. If it is on the right side, I see a significant improvement. If it is on the left side, I see the improvement is insignificant, because this Kohli was already maintaining. That is our understanding. Now, what is the point of appointing a coach? So either you can check like this, right or left. If it is right, significant, reject the null. If it is left, insignificant, fail to reject the null. Another way is you can, instead of checking right or left, you can just check the associated p-value. What is p-value? Wherever you are available. Yes, 56.5, you are here. Now the p-value refers to the green color hatching area. And clearly from this graph, green color hatching area is above 5%, because up to LOS, from infinity to LOS is already 5%. You have some more. So when your statistics is inside the line of significance, associated p-value is more than 5%. If associated p-value is more than 5%, it refers to insignificant improvement. If the improvement is insignificant, why do you want to pay a huge salary to the New Zealand coach? You think over. And we are not forcing you. Statistics is not forcing you, but statistics is making you to think. You want to continue paying 2 crores, 3 crores? No. You can hold his appointment or you can terminate his appointment. Whichever is feasible, please proceed and make a decision. This is a decision made. You should make a decision. Statistics is telling you, please make a decision. But which decision is feasible? What is your contract with the coach? You consider all of those things and come out with a practical decision. But statistics is telling you, you have to make a decision now. But uh, when when the p value is above the line of significance, you have to reject the null. See, reject the null means again you have to make a reject the null means yes, null statement is invalid. Null statement invalid means now the coach is having an effect. If the coach is having an effect, the coach is having an effect, you check whether the effect is positive or negative. It is positive. So you make the appointment permanent. See, there are two scenarios. One is p value below 5%. P value below 5% means reject the null. Reject the null means the study is significant. You have to believe the findings. But when it is on the other side means p value is more than 5%. P value more than 5% means the information is insignificant. What is the information coming? There is an improvement, but improvement is meager. So you should not consider that improvement as an improvement. Do you understand? So you have to know fully aware of what are you doing, how are you using the data. Now we are talking about an improvement of 1.5 in the batting average. Improvement of 1.5 is not a significant improvement. So I don't want to believe this. The information coming from the data is unreliable. When to believe the data, when not to believe the data. Believe the data when the associated p value is below 5%. After believing, see whether it is positive or negative, helpful or harmful. If it is helpful, a decision will be taken. If it is harmful, some other decision will be taken. But it's a decision making opportunity for you. Are you with me, all of you? But when p value is more than 5%, the information is unreliable. When information is unreliable, that time, you have to make a decision accordingly. You are doubtful. See, there is improvement, but you can't say, no, the coach is, useless. That you can't say. So that is why I'm telling you, you can also hold him. Or you don't want to pay a huge salary, for another 2 months. You can even, boldly terminate him. That's up to the leadership, no? All of you, do you understand now?
Yes.
Thereafter, I don't want you to complicate this subject by, every time visualizing the graph, seeing the line of significance, checking whether your statistics are right side or left side. Please do not do all this exercise. I have taught you, you have also understood. Am I correct? Now I want you to only look at p value. P value below 5%, reject the null. That means the information is significant. Some useful information is coming to you. Use the information wisely and make a decision. Another scenario, p value more than 5%. The information is insignificant. The effect is insignificant. If the effect is insignificant, what should you do in that scenario? Please act accordingly. But the data is not highly, not really reliable. So in that situation, so when to use the data, when not to use the data, you have understood clearly. Okay, all of you, is it correct? Good.
Yes.
Okay. So now again, I'm sharing my screen because I'm going to show you some case studies now. Yeah. Before going to the case studies, how to hypothesis test selection, I tell you. For hypothesis test selection, y variable, you please check whether your y variable is continuous or discrete. But what I have written, y variable is continuous. Your x variable is attribute. Y variable is continuous, x variable is attribute. Now, x variable exists in how many levels? You have to ask yourself. How many levels? If you are studying the New Zealand coach separately, it is one level. If you compare the New Zealand coach and Australian coach, it is two level. If you compare New Zealand coach, Australian coach, and also South African coach, it is more than 2 level, 3. Right? The level is 2 or more. You have to do a test called ANOVA. We identify the level from X variable. Please note the conditions. Y variable should be continuous. You know what is continuous? Measurable. For continuous data, we can calculate average. Please understand. So, whenever your Y variable is continuous, the hypothesis test is generally called as test of averages. When the X variable level is 2 or more, the specific test you should go for is ANOVA. When the level is exactly 2, now you have an option. You can go for ANOVA or you can go for 2 sample t test. Do you understand, all of you? Or if the level is 1, then you should go for 1 sample t test. Now do you understand why I wrote 1 sample t test earlier?
Sir, are we going to discuss ANOVA and to sample T testing and all those?
Yes. Right now.
Okay.
See, I want to know some yes or no from all of you, just to understand you are not sleeping right now, and just to understand you are awake, as well as you follow me fully. Even if you don't understand a small percentage of what I'm speaking, then that will lower your confidence. Then you will lose grip on the subject. Very important, right? So far now I am talking about hypothesis test selection. How to select the test? You need to find out whether your Y variable is continuous or not. If it is continuous, then definitely your hypothesis test is coming under the family of test of averages. Clear? Under the test of averages, you have ANOVA, you have 2 sample t test, you have 1 sample t test, you also have 1 sample G test. You also have what? Now, when to go for ANOVA? When the X factor you are studying
More than
has
2.
Or attribute.
More than 2
X
attributes.
factor is attribute, but it should have 2 or more
2 or
levels.
more. Yes.
I give an example. The adhesive strength of the paint applied, is it improving or not? When I use 3 types of primer, how many types of primer I use? 3 types of primer I use, and I want to understand whether the change in the primer can make a significant change in the adhesive strength. If changing the primer can significantly change the strength, adhesive strength of the paint, you know what will I do? I will exactly find out which primer leads to a maximum adhesive strength. After that, I will only use that primer, stop purchasing the primers from other sources. Earlier, my belief was, all primers, I can use in the painting process. But after doing a little research, I understand I cannot use, all primers blindly. I really have to find out whether the primer has a significant effect on the adhesive strength. What do you think, all of you? Primer will have a significant effect on the adhesive strength or not?
Yes, sir.
Yes.
That means you are telling primer is critical to adhesive strength.
Yes.
That means your statement is alternate hypothesis.
Yes, sir.
And the opposite, primer is not critical.
Null hypothesis.
Null hypothesis. The first step is over. Second step, alpha equal to 5%. That means you should consider 95% confidence level. Okay? So second step is also over. Third step, selection of hypothesis test. What is your Y variable? Adhesive strength. Is it continuous or not?
Continuous.
Yes.
Adhesive strength is continuous, measurable.
Yes.
Now, what is your X variable? Primer.
Attribute.
Primer attribute. Primer 1, primer 2, primer 3. It's an attribute data. Correct? It's a name, right? Name is attribute. Now, how many levels your primer has got?
3
അത്
levels.
അത് പറയാൻ പറ്റില്ല എന്നാണ് പറഞ്ഞു.
3.
3 levels. So, what is the test you should go for? When the level
ANOVA.
is more
ANOVA.
than
ANOVA.
you got it. This is the situation you have to check, and then you should go for ANOVA. Another scenario. Imagine you are working with 3 suppliers. When I say supplier 1, supplier 2, supplier 3, it's an attribute data. 3 suppliers, you are checking, the material quality. Material quality is, let us say, strength of the material. Which supplier is giving you the better strength in the material you require? Now you have to find out which supplier is good. Now what test you will do here?
One sample T.
ANOVA again.
ANOVA.
ANOVA again. There are 3 suppliers. There are 3 suppliers. See, one sample T test means you have to test the suppliers one by one. 3 times you have to conduct a test to make a conclusion. Not required. In one go, you can, compare all the 3. That is ANOVA. Because when you perform the test, multiple times, it will be time consuming and it will be costly. Error will also be more. That is a big reason. Because every hypothesis test comes with a risk of 5%. Do you understand? Every time we decide based on the sample, we must agree there is a risk we are experiencing. Yes or no? The weather department is, predicting a rainfall and they declare, a holiday for all the schools, colleges, government offices, private offices. But the next day, there is no rainfall. Data comes with the risk. Yes or no? Statistics, cannot, come with no risk. Even though
Sir,
you
one
studied, you
question.
found something, still there is a chance your expectation may not be true. But that risk of, making a wrong decision, we should ensure it is maintained below 5%. Hope you all understand. Now let me show how we can do the hypothesis testing in Minitab, right? For that purpose, the
So,
Minitab screen is already available, and I'm going to the Excel
sir, one
and
question, sir.
this. Please.
Just now regarding the adhesive, the 3 primers, or in case of suppliers, if there are 2 kind of scenario where 3 of the 3 primers are compulsory needed to manufacture that adhesive. Another case, we are studying 3 primers, out of which each primer can be used only one time on that adhesive. We have to compare which of the primer is good. So in both the scenarios, we'll use ANOVA, or because in one case, either one primer or one supplier has to be used. Like it's not combined. In that case, also we can use ANOVA.
Oh, first case, you tell me one primer. No, you have
Uh,
to,
just now,
yeah.
yes. Just now, sir. Like for example, in an adhesive, one is in that adhesive while manufacturing, you need to put 3 primers, and then
Okay.
now we are doing the
No, see,
study to which
different. See.
primer.
No, wait. You are telling, primer layer 1, primer layer 2, primer layer 3, right?
Yes, sir. And in
Yeah.
another
See,
scenario,
you can
only
have 3, layers, but all 3 layers are same primer only. Okay? Then apply a layer of primer 3 times, nothing wrong. That concept is different. But what we are talking is we have 3 types of primer. Primer A, primer B, primer C. Okay, I'll come to your question, right? So wait. See here, are you seeing all of you? Primer 1, primer 2, primer 1, primer 2, primer 3, primer 3. Can you see here, all of you?
Yes, sir.
Yes, sir.
Primer data is available here, and the corresponding adhesive strength is also available here. How to select this? Okay, this one. Yeah. Oh God. Select this. Okay. So I just select these things. Later I will remove. No problem. Control C. Now I go to mini tab. I just paste all of them here. Right now I don't want this column. Let me delete this. Okay. Now you see all of you in this column 4, I have the primary information and here I have the adhesive strength. Every primer is tested how many times? 1, 2, 3, 4, 5, 6 times. Can you see? Primer 1 is tested 6 times. Primer 2 also tested 6 times. Primer 3 also tested 6 times. Totally how many experiments? 18 experiments.
18, sir.
18.
Now with these 18 experiments, I am going to find out whether the primer has a significant effect. If primer has a significant effect, I will find out which primer is useful for my adhesive strength. The one that gives more adhesive strength is useful, isn't it? Very simple. That is what I'm going to do. Now, what is Y variable here?
Sir, the adhesive
Adhesive
strength
strength.
is the
Adhesive
Y
strength.
variable.
Adhesive strength.
Very good, which is continuous. What is X variable here?
Primer 1 and 2.
Primer
Primer.
1, primer 2, primer 3.
Attribute data. How many levels for the primer?
3.
3
3.
So
levels.
what is the
3.
recommended hypothesis test?
ANOVA.
ANOVA.
Very good.
No.
So go to stat, go to ANOVA, go to 1-way ANOVA. Look at the description. Can you read out one of you? Determine.
Determine whether the means of 2 or more groups differ.
I have 3 groups now. Whether the average adhesive strength produced by primer 1 compared against primer 2, primer 3, is there a significant difference? So let me click this. Now the response data in one column. Yes. Response data in one column, which come here. Place your cursor here. Then only left side will be visible. This is the response, column 5. So click and select. Where is your factor? Factor is primer. Select this column 4. Hope you understand now how I input the data. Now go to option. Confidence level. What is the confidence level? Normally we should work 95%.
95.
Unless and otherwise it is specified, it is always 95%. If you change it, if your company want to change to 95%, that means they want to reduce the risk from 5% to 1%. 95 is the normal thing. Now, do you want to keep your test one-sided or two-sided? If specifically, if you know one-sided, you are only looking at the better adhesive strength, you can say upper bound. Or if you are looking for a lower adhesive strength, you can say lower bound. Or if you don't know, then keep it upper bound. Now, like right now, I'm going to keep it two-sided. And see here, there is a tick mark here. This must be tick because what is written here? Assume equal variance.
Equal variance.
While performing ANOVA, you either have to assume equal variance or you have to perform a variance test separately. Let's not complicate. Let's assume equal variance. And now you give OK. Give one more OK. Now Minitab has done all the job for us. Minitab has done all the job for us. Now, please note, there is a 95% interval. There is 95% interval plot. There is 95% interval plot available. Now this is ANOVA table, come here. I want you to look at the p-value of can you see the ANOVA table here, all of you? Analysis of variance. The first row talks about primer. What is the associated p-value?
0.015.
0.015, sir.
Now you just have to tell me whether the p-value is above 5% or below 5%.
This
Below
5%.
5%.
So I must reject
Reject
the
null.
What should have been your null in this case?
Primer 2 is not.
You have to write this very carefully, all of you. Look at what I'm typing. This is very important. Primer has no effect, or primer type has no effect on adhesive strength.
Assistant.
Then H1 will be primer type
Has
Has effect on other system.
significant effect.
significant effect on adhesive strength. See, in statistics, adding the word significant is helpful. Now, alpha is 5%. Alpha is 5%. And now we did the study and we found p value below 5%. Reject the null. Reject the null means alternate will become valid. What alternate is telling? Primer has a significant
Significant
effect.
effect.
Now you go and look at the graph. Which primer is giving you a better strength?
Primer 2.
Primer 2.
So primer 2 should only be used in your painting process so that adhesive strength can be more. Are you with me, all of you? And visually we can understand that. I'll do one thing. For primer 2, when I draw a horizontal line, it is not, what do you call it? It is not cutting the entire interval of 1. It is not, disconnecting the entire interval of 3 also. Have you noticed?
Yes.
Yes, sir. Okay.
Which confirms at least 95% of the time, the primer 2 can give you a better adhesive strength. But still there is a 5% chances there that primer 2 can give a lower strength and 1 and 3 can give a strength better than 2. The risk in the statistics. Are you with me, all of you? But the risk is limited to what?
5%.
5%. Because the interval we considered here during the decision making is 95%. Are you seeing a full interval of 1 and 3?
Yes. Yes.
The 95% interval of 1 and 3 is considered, but still the average of primer 3 is on the upper side. So that definitely 95% of the time, your primer 2 is going to win over primer 1 and 3. Meaning, if you repeat the test 100 more times, 95 times, the same result will come. 5% of the time, the opposite result can come for any reason. The confusion is reduced to 5%. Can you see that? Do you understand or not? 5% of the time, yes, you see a different result. But 95% of the time, you see what? Primer 2 improve, giving a better adhesive strength. So I am at least 95% confident. And now I am proceeding with primer 2, finalizing the primer 2. Are you with me, all of you?
Yes, sir.
Yes, sir.
That's all. That means you have become a master of ANOVA now. It's called one-way ANOVA. I'll now tell you the another scenario of using ANOVA. Let's do it in some other. This is a kind of painting process. Now let's take a hospital scenario. LabTat is the file. LabTat. Where is LabTat? I have to organize this. It is here. Laboratory TAT. So much is written here. Now imagine you are running a big hospital and you are into hospital management. And in your hospital, maybe you are the CEO of the hospital, you are maintaining 4 diagnostic laboratory. And the data what you are seeing here represent the TAT time, the turnaround time for performing a particular diagnosis. As a CEO of the hospital, what is your expectation? Your expectation is all the laboratories should follow a standard procedure and so should release the report within the standard timeline provided. Yes or no? That means the
Yes, sir.
turnaround that means the turnaround time should be equal. If TAT 1, TAT 2, TAT 3, TAT 4, if all are equal, that is your null hypothesis. If they are unequal, that is your alternate hypothesis. Now, what is your output variable here?
Turnaround time.
Turnaround time.
Turnaround time is measurable. And what is the input variable or the factor?
All the labs, lab
Laboratory.
1 to lab
Laboratory is the factor. How many labs you have?
4.
4.
Four.
So level is 4. Now tell me what is the hypothesis test you should do?
ANOVA.
ANOVA. So I copied this data already. I go to Minitab. I place the copy data here. Now tell me where should I click?
Stat.
Then
ANOVA. Control ANOVA.
then
One
Bal.
way.
One way.
one way.
One way.
If you are dealing
One
with
way.
only one factor, it is one way ANOVA only. So click that. Now response data in one column or separate column? Separate column. Four laboratory, 4 different column, isn't it?
Okay.
Then you click here under the response. Now you have to select all the lab 1, lab 2, lab 3, lab 4. Click and select. Now go to options. Confidence level 95%. Keep it two-sided. See here whether the tick mark is placed or not. Tick mark should be placed. Now you give OK. You give one more OK. The ANOVA is done for you. Now, are you seeing the interval plot? By seeing the interval plot itself, are you able to understand?
Yes,
I'm
sir.
drawing this turnaround time. It is not disconnecting any of the interval of the other labs. I'm drawing a line here. I'm not able to see any, other interval getting disconnected. Clearly, there is a statistical significance. Yes or no?
Yes, sir.
If you don't want to read like this, go to your ANOVA table. Go to your
So
ANOVA
what
table.
about between lab 1 and lab 2 if we want to analyze?
Yeah, I'll come to that. First, ANOVA is overall comparison. Now here is the factor. Look at the p-value.
0.
Significant. So reject the
All
null.
that we want is p-value less than 5%. So reject the null. That means lab is significant. Factor lab is significant. That means if you need quick results, you should prefer laboratory 4. Yes or no?
Yes.
Whenever you need quick result, you should prefer laboratory 4. And laboratory 3 must is certainly be punished because they take very, very longer time. Or they're always late. Can you see that? So some improvement is definitely required for laboratory 3. Even 1 and 2 are found to be taking significantly higher TAT compared to 4. Now, if you are the CEO, I will put all the 3 laboratory under the shadow of lab 4. They all can take up a training under 4 because they are performing the same test. They can learn and then follow the same procedure because all of them were given the same facility in the same hospital. Do you understand why am I arranging such a training program? Because I see a statistical significance. This difference cannot be considered as random, isn't it?
Yes, sir.
There is a systemic issue. Some improvement is required. See whether training can help. See whether some reconditioning the instrument is required, or see something else is required. Do you understand, all of you? Now coming to your question. Sir, if I want to only compare 1 and 2, if you want to compare 1 and 2, you can do a test on 1 and 2 separately. You need not input column 3 and lab 3 and lab 4. That way also you can do an ANOVA. Let us do it. stat, ANOVA, one way. Now I don't want to input all the columns. I want to only input lab 1 and lab 2. All other things remain same. Okay. One more okay. Now what do you see? If I draw a horizontal here, is it going without interruption, or are
No,
there disconnect happening?
disconnect is happening.
So it is actually yes, bisecting. So in such a case, there is no significance. The null hypothesis cannot be rejected, fail to reject. Because what is your null hypothesis in this case? That or equal. It's a statement of equality.
P value.
Go and see. Go to the ANOVA table. Look at the p value.
More than
More than 0.5.
0.59, 0.05. Fail to.
reject the null.
That means there is
Alternative, yes.
no, fail to reject. There is no significant difference in the TAT of lab 1 and lab 2. So whether you give your sample to lab 1 or lab 2, you will get it at the same time only. Do you understand, all of you?
Sir,
Yes, sir.
can I say by the data 0.766 that 76.6% of the data comes in the common area of lab 1 and lab 2?
Yes. Yeah. When you visualize the lab 1 and lab 2 bell curve, there is an overlapping of 76%. So when there is an overlapping of 76%, that means the risk associated in reading the data is 76%. That much risk is not permissible. I am comparing you and Vikas, and I want to give a promotion. 76% of the criteria, you are performing same only. Only believing the 24% criteria, I don't want to decide on the promotion. Logical, right? You should perform better, at least in 95% of the criteria. Then I will give you promotion. Something like that. Hope you all understand, the one-way ANOVA, how it is used using Minitab for two different cases. One is, the painting. Another one is for lab TAT. We have seen factor with 4 levels. We have seen factor with 3 levels. And we have also seen factor with 2 levels. 2 level is only lab 1 and lab 2. When factor with the 2 level, there is another alternate method is also available. You know what is that? If you have listened to me very carefully, then all of you must be able to answer this question.
If the level is exactly 2, we have to go on
Two-sided
two sample t-test.
Very good. We can also go for a 2 sample t-test. But the problem with 2 sample t-test is, even if you use Minitab software, you will not get the interval plot. But everything else, you will get. Let us see. Let's compare lab 1 and 2 with the 2 sample t-test. Stat. Go to basic stat. Come to 2 sample t. Now description is coming. Can one of you read out the description?
So determine whether the mean differs significantly between two groups.
Very good. Click that. Now both sample in one column or each sample in one column?
Each sample in one column.
Yeah. Sample 1, lab 1. Double click. Sample 2, lab 2. Double click. Option. Ensure the variance is tick. Ensure confidence level is 95. The hypothesized difference. The mean TAT for lab 1 minus mean TAT for lab 2. If they are equal, the difference will be 0. This is Minitab way of defining null hypothesis. So alternate is, you can say not equal to, you have two options. When you say not equal to, it's a two-tailed test. When you say difference is more, then it is right tail. When you say difference is less, it is left tail. Let's keep it two-tailed. Give OK. Give one more OK. And now the Minitab has performed the 2 sample t-test for us. What is required? We should refer to the p-value. Tell me what is the p-value?
0.76.
So same decision?
Yes, sir.
Only thing is the visual, interval plot is not produced. Are you with me, all of you?
Yes, sir.
Sir, here I have a question.
Yes,
Sir.
sir.
So in this case, we are not defining that minimum is better, higher is better, the takt time and all. So how the system will selecting that which is better and all, sir?
Yeah,
By
first of all, we are checking whether 1 and 2 are significantly different or not. If the significant difference is found, then you can look at the mean value. You see, look at the value. One laboratory 1, TAT is 178.4. Laboratory 2, what is the TAT? 178.9. Now, who is faster as per the data?
lab 1.
But you should not declare that now statistically.
Yes.
Statistics will not allow you to declare this finding.
Okay.
Because statistics will allow you to declare the finding only when p-value is below 5%. Where whoever is using statistics, using data, please make sure you publish your findings only when the associated p-value is below 5%. You are doing a research, you have come up with some findings, but your findings can be published only when the associated p-value is below 5%. Otherwise, the risk is more than the permissible level. When risk is more than the permissible level, many people will try your findings and then they may report your findings are wrong. Yes or no?
Yes, sir. So that means you mean to say in a 4 lab, any one lab will come under the below 5%. It will declare as a below
Wait,
5%. From that, we have to
wait,
choose
wait,
that.
wait. If you take 2 lab at a time, everything becomes, a case of 2 sample titers. You can take 1 and 2, you can take 2 and 3, you can take 3 and 4, and you can take 4 and 1. You can, this way you are conducting 4 2 sample titers to, finally find out which is best. And there is a shortcut. Shortcut is ANOVA. All the 4 you can take, simultaneously. So when ANOVA is possible, when a shorter route is available, please take it, because in statistics, the longer the route you take, the more the risk. So ANOVA is best preferred, when the number of factors, the levels are more. And when you take 2 factors, levels 2 at a time, then you can do ANOVA also, you can do 2 sample t-test also. And now there is one other possibility. You know what is the possibility? If you want to test each lab one at a time, you want to test each lab, test each lab one at a time. Because in your hospital, let me go here. In your hospital, if the TAT is if the TAT is less than or equal to 175 minutes, then only the laboratory can function. Then only the laboratory will be authorized to set up their facility in your hospital. What is the requirement? That must be
175 minutes.
less than or
Less
equal to
than or
170.
equal to.
Do you see a equal to symbol here in my statement?
Yes.
Yes, sir.
Then only it is H0. Then what is H1?
Greater than 170.
This is right tiled test. This is a right tiled test. What is the test I should do?
1 sample t-test.
Very good.
Or 1 sample is a test.
No, t-test only. Z test is not suitable here. I'll tell you. So alpha is 5%. That means your confidence level is 95%. Now 1 sample t-test. How to do it? Go to stat, go to basic stat, come to 1 sample t. There is a description. Determine whether the mean of a sample differs significantly from a specified value. What is the specified value? 175. Sometimes it is called reference value. Click that. Sample in a column. Yes, click that. Lab 1 I want to check now. Perform hypothesis test. What is the reference value or hypothesis mean? 175 minutes. What is the option? 95% confidence. What is your test? Right tail test. Give okay. Give one more okay. Look at your p-value. How much it is?
3%.
P-value is below 5%. That means you reject the null. Now, what is the mean TAT?
178.3.
So this lab is qualified to set up the facility or disqualified?
Disqualified.
Disqualified. Because your null is this, null is, you believed the lab that, they will maintain a TAT of less than 175. But the test is telling you reject the null. Reject the null means don't allow them to set up the facility. They are not eligible. Are you with me, all of you? Shall we do the same test for lab 2 and check, whether they qualify?
Yes, sir.
Stat, basic stat, one sample T. Now, instead of lab 1, you should proceed with the lab 2. Everything else is same. You don't have to change anything. Now, again, p-value is less. Again, p-value is less. Oh, they have not changed, huh? Oh, we changed it, but still, here also, this is also disqualified. Yes or no?
Yes.
See, why I disqualify? Because p-value is below 5%. So data has a significant no information. That significant information is, it is not suitable. Now lab 3, I think nothing will qualify. So stat, basic stat, one sub. Now since nothing is qualifying, now the hospital CEO has changed his mind. He is okay to give what? Extra 10 minutes. Now laboratory 2. Everything else is same. Now 185 is the limit. Oh God. Now fail to reject. Fail to reject means they are able to maintain the condition of now keeping the turnaround time 185 and below. Am I correct?
Yes. Yes, sir.
So in Minitab, we have understood one sample t-test, two sample t-test, and one way ANOVA. Do you remember, all of you, Maggie was banned, some years before? Do you know why it was banned? Due to?
Yeah, because of the lead content.
Correct. Because of higher lead content. Lead content is a measurable characteristics. And Maggie is the, factor studied. Whether Maggie has a higher lead content or not. That is a factor. And that factor, only one product we have considered. Only Maggie brand was tested. So it's a case of one sample t-test. Because Y variable is continuous, X variable is Maggie, the level is only one, so it is one sample t-test. And what is the t-test reference value? Reference value was given by whom? FSSAI. FSSAI has given the reference value. And food inspector has collected random sample from the market. And he found that the average lead content is higher in the sample. He might have checked, the test the 2-3 times, and then he presented the data and filed a case. And Maggie was banned. We all know the story, isn't it?
Yes, sir. Yeah.
Now there is one other twist. The one other twist is, it's not the food inspector who tests the Maggie quality. It is the quality head within the Maggie. He want to test their ability to maintain, the lead content within the reference value. Now, who is conducting the test?
Quality guy from
Quality head.
Nestle.
Quality production
The
manager.
company, the quality head, a senior person, let us say is a senior person, and let us say he has the power to refer to the historical data. He has the power to refer to what? The historical data. What is historical data? The Maggie is, the Nestle is producing Maggie for several years. And the last 1 year data he want to refer. Yes, he is allowed to refer. Possible or not?
Yes, sir.
Yes, sir.
Okay.
If such a possibility exists, then you can do a one sample G test instead of one sample T test. Are you with me, all of you?
Yes, sir.
You can, you can do the one sample G test. So what is the condition? When can we go for the one sample G test?
If historical data
We
is
know the
available,
historical data.
If historical data can be considered as the population data. Historical data can be considered as the population data. That means population characteristics are revealed now. Very, very rare scenario. No company will, give access to the historical data easily. But if the access is given or the information is shared, that's the time you can go for one sample G test instead of T test. Are you with me, all of you? Do you understand?
Yes, sir.
yes.
Now, to understand that, I am bringing one other example. A company manufacturing cooking oil, they declared that the fat content in the cooking oil is below 15%. You are okay with below 15%, or again a food inspector, he want to check whether the fat content is below 15% or not. This is the condition. Now let us write the null hypothesis, alternate hypothesis. What is null here? Fat content is
That one is
less
below
than or equal to 15%.
15%.
What is alternate here? H1. Fat content is more than
More
15%.
than 15%.
It's a right tail test. Please note. Right tail test. And alpha is 5%.
5%.
What is the recommended test here? I don't know whether it is T test or G test, but definitely one sample test. And now there are two possibilities exist. Historical data or information, needed information shared. You know what is the needed information? Population standard deviation. No, 10, 15 number. So population standard deviation. Population standard deviation is known. Are you with me, all of you? If this is done, if this is the fact, that's the time you can go for one sample T test. So let us assume the population standard deviation sigma is 2.6. What is the test I should do now?
One sample Z test.
Let us do it. Go to stat. Go to basic stat. One sample G test. Click. One or more sample in a column. Yes. What is that column? Fat content. Known standard deviation. This is nothing but population standard deviation. Do you understand how are we using? This we are not giving, while doing the T test. Now perform the hypothesis test. What is the fat content? 15 or below. Option 95% confidence level. It's a right tail test. Okay. One more okay. Look at the p-value and tell me. P-value is how much? Below 5%. So what should I do? Reject the null. So what is the action required? What is the action? What is the action I have written?
Ban.
Let's see. Yeah, ban the cooking oil. But please note, if you don't want to be too strict, you can write something else here. Instead of ban, you can warn the cooking oil company. Yes or no? You can be strict also, or you can be lenient also. I leave it to you. But statistics is giving you a strong signal that something is going wrong. Are you with me, all of you? Do you understand what I explained today?
The Z test, why it is because p value is less than 5 percentage. What should we have to check in that?
See, p value less than 5% means it is significance or not?
Significance.
Significant. And after knowing that it is significant, you look at the mean value. What is the fat content they maintain?
16.6.
But
Okay.
they printed
Fine.
15%,
Yes.
but the mean value is 16.6, and attached the associated p value is below 5%. Then how can you allow them to continue the sales?
Understood, sir. I didn't verify that 15.
Yeah. We have to look at See, p value will first tell there is a significance. Whether it is good or bad, you have to look at the data. If it is good, you can allow, you can give them the license.
Understood.
Now, sometimes in a t-test, in a two-sample t-test, while performing a two-sample uh, t-test, you may want to study a before-after scenario. Let us say a diabetic treatment. A diabetic treatment. A patient is given a treatment for diabetic, and his sugar levels, reduced. Now you have to prove, yes, my treatment is effective. My treatment can significantly improve the diabetic condition. All right. Now, diabetic condition is measurable. Y variable is measurable. For example, fasting blood sugar. What is that? X variable is the treatment. The treatment. Now, what is that? What is that we want to study?
Before and after.
Yeah, before versus after study. Before and after. Now, in this condition, you have to perform a parity test. What is the test you should perform? Parity test. Are you with me, all of you? This can be used for solution validation. So far, we spoke in terms of root cause validation. Now, parity test can be used for solution validation because after the results, your Y variable improve. Do you understand, all of you?
Yes, sir.
Whether I have an appropriate example. We have one column of data, two columns of data required. Before as well as after is required. Okay, no worries. Here is your parity test. Extract MTW. Okay. We'll do that. We just go to file, go to open worksheet, click here once, paste that file name, open, save OK. Now you got the data. Oh, what is this? Mat A, Mat B. What is that? Mat A, Mat B. You see here? A shoe company want to compare two materials A and B. All of you please understand the context. To a shoe company, last problem for the day. A shoe company want to compare two material A and B for use on a soles of boys' shoe. In this example, each of 10 boys in a study wore the special pair of shoes with the sole of one shoe made from material A and sole on the other shoe made from material B. The sole types were randomly assigned to account for systematic differences in wear between left and right foot. After 3 months, the shoes are measured for wear. Okay. So there is material A, there is material B, right? The data is available. And now we understand what is material A and material B. And then the wearing of the thing is, somehow measured. So Y variable is the wear rate or something. Okay. See here. Do you now understand, all of you, what is mat A? Mat A means material A. Mat B means material B. The wear rate of material A is measured, and this is wear rate of material B. That means the what you call the sole is now modified. Earlier A was used, now B was used. This is before, this is after. We want to understand whether there is a significant difference in the wear rate. Can I do a paired t-test here?
Yes, sir.
Go to stat, basic stat, paired t-test. Where is paired t-test? Yeah, here. Now each sample in a column, sample 1 is material A. The sole is made of material B. Now A is replaced with B. Now go to option, confidence level 95, difference 0, not equal to, and give OK, one more OK, and your p-value is very, very low. That means a significant difference exists. If it is wear rate, look at B. No. B wear rate. I think you need to understand whether you need a lower wear rate or higher wear rate. If it is wear rate, in my opinion, the wear rate has increased. So it is not it is not appropriate to change from sole A to sole B. So I mean material A is the best. This kind of test is called what? Paired t-test.
Paired t-test.
Why do we call it paired? Because we put the sole on the same shoe. First 3 months, the performance is studied, and again next 3 months, sole B, the material B is used. Similarly, before after test, if you that means the source of data is same. If source of data is same, the test is called parity test. So how many tests we discussed today? Please, one of you can you just list out, then we will wind up for the day.
5.
Okay, 5. What are
ANOVA,
the 5? ANOVA,
2 sample t-test, 1 sample t-test, 1 sample z-test, and paired t-test.
Very good. And what is the commonality? What is the common thing with all the tests? In all the tests, Y variable is?
Y variable is continuous.
Very good. And in all the tests, our decision-making statistics used is average.
Average. Test of averages.
Correct? Yeah. And all of them are now commonly called as test of average. The family of test of averages we mastered today. And I want you to use this knowledge for validating any claim, including a claim about root cause. Once the root cause is validated with the associated p-value, then you can do a Y-Y analysis for the root cause. And whatever the solution you arrive, you can confidently implement the solution. Are you with me, all of you, on this?
Yes,
Yes,
sir.
sir.
Yes, sir.
So we will further enrich our understanding on the same subject. Again, we'll open up the discussion, but I want a lot of participation, no, particularly when we talk about these kind of statistical tools. It's important that you also ask questions, participate, and answer, the queries. Then it will certainly be, very interesting. Okay, that's it from me for the day. All the best.
Thank
Okay.
you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Good night.
We are going to
Right.
Thursday.